Hi everyone, I'm Jeff. Welcome to OPPO Electricity Lab. Today, we'll talk about charging. In the industry, we all aim to increase the power of charging, as higher power will deliver faster charging. Take 65 watt Super VOOC, which is our fastest charging tech for mass production. It can fully charge a 4000 mAh battery in about 30 minutes. This time, Super VOOC gets faster. But it's not just about a faster Super VOOC. We want to bring more possibilities here. So first, let's talk about the upgrade on speed. I'll charge a prototype here. The power remains a secret at this moment. We'll take a look back later. 2020 marks the 6th anniversary of VOOC's creation. 6 years ago, we launched the first phone equipped with VOOC flash charging, Find 7. We have continued to push back the frontiers, and now we have 65 watt Super VOOC wired charging and 40 watt Air VOOC wireless charging. Be it wired or wireless, we maintained the record of having the fastest charging with the highest power for mass production. I'm proud to say that our charging tech has been always in the lead. Things like our direct charging architecture, the dual cell in series connection, the isolated charge pumps for wireless charging, they all speak for our tech strength and innovation capabilities. Today, we have VOOC, Super VOOC, and Air VOOC. They have literally changed the life of our 157 million OPPO flash charging users. Our users don't have to charge the phone overnight. They are no longer confined to where the adapter is, waiting for the phone to be fully charged. We redefine what you can do with 5 minutes, which is exactly our aspiration with flash charging, to make the best of the fragmented time. As you may recall, our slogan evolved from 5-minute charge 2-hour talk to 5-minute charge 4-hour video watching on Reno 4 series. We can do more and more with 5 minutes. As the 5G era arrives, we see better hardware specs and increasingly more apps, both of which cause more power consumption. But we cannot infinitely increase the battery size. Therefore, in the 5G era, charging efficiency is a must. I've said this before, leading is challenging, but we are persistently pioneering. In our tech communication conference last year, many people asked me whether OPPO will keep launching a higher power fast charging tech. Well, actually, at that time, our team were already working on the next generation of flash charging. And now, introducing the brand new OPPO flash charging 125 watt flash charge. So far, this could be the technology that has the highest power for phone charging and is also available for mass production. The power is even higher than that of most laptops. Now, let's take a look at the prototype. 3 minutes have passed and it's now 33%. That's almost twice as fast as the 65 watt Super VOOC in mass production. As I've mentioned, it's not just about being faster. On 125 watt flash charge, the power adapter uses the Type-C port, which allows for better compatibility. Be it our proprietary VOOC and Super VOOC protocols or other protocols as PPS, PD, and QC, they are all supported. That is, the power adapter of 125 watt flash charge can charge almost all of your electronic devices, delivering high power fast charging. Be it a smartphone of OPPO or other brands, or even tablets, laptops, 125 watt flash charge takes care of all. So, how fast will it go? Take a look at the curve here. It hits 41% in 5 minutes and fully charges the phone in 20 minutes. And when I say 20 minutes, there's a prerequisite. The temperature of the phone stays under 40 degrees Celsius. But when the temperature is ideal, it can go as fast as 13 minutes to fully charge the phone. Feel free to follow me on my account on Weibo, and I'll post more videos there. Now, when the power doubles, that means the current doubles as well, from 6.5 amp to 12.5 amp. Therefore, the impedance of the battery shall be reduced to sustain a higher current. We adopted a double 6C cell battery with a higher C rate. It is also equipped with the MTW or multi-tap winding technology. As you may remember, on Reno Ace, we placed the anode and the cathode of the battery in the middle instead of the traditional two ends. That was the MMT technology, or middle tap. Now, with MTW, taps are everywhere. Take a look at the cross-section of the battery. It looks like a layer cake. Electrodes can be found on each layer of the cake. The path of electric charge movement is again reduced, resulting in lower impedance, which allows for the input of 12.5 amp current. So the double 6C cell battery, in combination with the MTW, is definitely one-upping the previous solution. It has raised a new bar. In physics lessons at school, we learned that power equals voltage times current. So we have talked about how we upgraded the battery to sustain a higher current. But what about the voltage? We need to think about how the phone will convert the 20-volt voltage output from the 125-watt charger. What we've done is we adopted 3 charge pumps in parallel connection, and the conversion efficiency is up to 98%. The adapter produces 20-volt 6.25 amp, which will then be converted by the 3 charge pumps into 10-volt 12.5 amp for the battery. In this process, each charge pump will only have to convert 20-volt 2.1 amp, which is around 42 watts. This division of labor protects the charge pumps from any overloading or overheating caused by a high current. Here's the highlight. Even though both the power and the speed have doubled, the temperature of the device is still under 40 degrees Celsius when charging. In addition, we have added 10 new temperature sensors based on the existing 4 sensors. These sensors are placed in the tap, the BTB, the PCB, and the USB port. It's fair to say that we closely monitor the temperature from the source. In addition, we have our unique impedance detection, which ensures reliability. Any anomaly will be immediately reported to the phone and the adapter. I always tell my colleagues, in developing fast charging, be careful and never burn someone else's house. Safety always comes first, compared with efficiency. The 5-fold safety protection is still the most reliable solution in the industry. Even if all these measures fail, there is still a redundant safety mechanism, our proprietary fuse protection. Apart from that, we have introduced the e-marker encryption on the Type-C to Type-C cable. Together with our 128-bit encryption algorithm, only when the adapter identifies the cable will the 6.25 amp current be generated. So that's wired charging. But what about wireless charging? In 2020, we put 40-watt air VOOC into mass production, which fully charges a 4000 mAh battery in 56 minutes. Since then, many people asked me, when will wireless charging reach the same speed as wired charging? Well, when it comes to wireless charging, here is the answer. 65-watt air VOOC. Now, I'll charge this prototype using 65-watt air VOOC and ACE2 using 65-watt super VOOC. Later, we will find out what is the difference, if any. On 65-watt air VOOC, it is equipped with our proprietary isolated charge pumps. In comparison with 40-watt air VOOC, they can convert a higher power and can avoid electrical breakdown caused by high voltage. So we managed to double the efficiency of 5-minute wireless charging. That's 25% charge in 5 minutes, the same speed as wired flash charging. As you will see on the curve, the 65-watt wireless charging runs almost the same as 65-watt wired charging. It can fully charge the phone in 30 minutes. People like wireless charging because they can just leave it on the pad and let it charge. But the age-old problem is speed. Now, as wireless charging is on par with wired charging, we can finally be at ease and leave the phone on the charging pad anytime. 5-minute charge, 25% juice. In terms of how it works, wireless charging is not like wired charging. For wireless charging, it's the two coils inside that transmit magnetic energy and convert it into electric energy. Therefore, the key to increase wireless charging power lies in the high power transmission between the two coils. And we solve this issue through a parallel circuit. A 40-watt coil and a 25-watt coil in parallel connection. That means 65-watt air VOOC features a dual TX and dual RX architecture, which contributes to a considerable increase of charging power. And the efficiency between TX and RX is as high as 88%. Now, that's easier said than done because when there are two TX coils and two RX coils, inevitably there will be frequency interference. With a systemic approach, we manage to minimize the interference and achieve the best efficiency of energy transmission. A higher power of wireless charging means more heat generated. At OPPO, our rule is that for off-screen charging, the phone temperature shall not exceed 40 degrees Celsius. So, in addition to the enhanced conversion efficiency, we made breakthroughs in cooling as well. Instead of having a larger fan on the pad blowing wind towards the phone, we transfer the heat through semiconductor cooling. The heat is transferred by a thermoelectric cooler, or TEC, under the coil into the air duct, and then blown by the fan out of the charger. In this way, the temperature remains under 40 degrees Celsius.
Again, just like 125-watt flash charge, we never increase the power at the cost of the phone temperature. Both charging speed and the temperature are critical factors of user experience. If you can't strike a balance here, that means you have to work harder and improve your strengths. In addition to dual coil, we are also verifying the solution using a single 65-watt coil. This is a big tech challenge. I would say this is our normal practice, as you may have heard that when the first generation VOOC was launched, we prepared 6 options in total. So that's 65 watt LVOOC with a speed as fast as 65 watt wired charging. Let's have a look at the prototype and ACE here. Within the same amount of time, both get more or less the same battery charge. In the beginning, I said SuperVOOC gets faster, be it wired or wireless. We have maintained the leading position. In terms of charging, there is a lot more to achieve beyond speed. In the 5G era, we propose convergence of everything. In charging, we also want to do more, not only for smartphones, but also for laptops, tablets, and even smartwatches, earbuds, and speakers. We want to make flash charge available to more devices in various scenarios. To make the flash charge a charging choice for more devices apart from smartphones, there is another essential prerequisite: to reduce the size of the charger while ensuring the power. Because in 5G era, there are a lot of smart devices. If the charger is heavy and thick, its use would be quite limited. Since we shipped the 65 watt SuperVOOC on our products last year, we kicked off another project, codenamed New Heli. It got its name because Heli explains this project well: small size, big energy. The best charging choice for the devices in 5G era. Introducing OPPO 50 watt mini SuperVOOC charger. This is how it looks. It's so small, so thin, just like a cracker, and it weighs like a raw egg. When I put it into my jeans pocket or into the pocket of my shirt, I don't quite feel it's there. I've kept it in this pocket from the beginning of the event, but I don't think any of you noticed that. I'm confident that it's the slimmest and the smallest 50 watt adapter in the industry. Actually, it's the smallest size allowed by safety regulations. The power density reaches 2.41 watt per cubic centimeters, not including pin. Compared to OPPO's previous 50 watt adapter, the power density is up by 3 times. And now let me talk about how we managed to reduce the size. It's all about 2 key components of the adapter: the transformer and the electrolytic capacitor. First, the transformer. Traditional transformers are over 20 mm thick. That's a barrier in our journey towards a 10 mm adapter. We must try to reduce the size of the transformer. And to reduce the size of the transformer, we need to increase the switch frequency by adopting new design and process. First, we have upgraded the switch of the transformer and introduced a gallium nitride, that is GaN, high-frequency switch, so the transformer can operate at a higher frequency. Our prototype has once operated at 800,000 Hz. Higher operating frequency, less winding, better PCB winding process, all result in a smaller size of the transformer. These are all significant improvements. We also use GaN to drive the transformer to a higher frequency. It's a breakthrough that we've been dreaming for years. In the past, we used the MOSFET for the switch, but this traditional material are not suitable for the high-frequency switch. On 50 watt mini SuperVOOC charger, we used the gallium nitride. Only this material will stand the frequent wear and tear. Based on the gallium nitride switch, we took a further step. We developed a brand new active clamp flyback, that is ACF architecture, and introduced ZVS. Before turning on and off the switch, it will clean up the voltage and the current in the circuit, so the wear and tear on the switch is reduced. The traditional transformer of a 50-watt adapter is more than 20 mm thick. As for our mini adapter, the transformer is only 8 mm thick. That's over half of the thickness saved. We have also integrated power semiconductor devices on the PCB of the planar transformer, achieving a higher level integration. In one word, on the basis of the GAN and a brand new ACF architecture, we have developed a mini planar transformer with our proprietary tags. The next thing to go for is the electrolytic capacitor. Take a look at the PCB of a traditional 50-watt adapter. You will see from the picture that the biggest component is the cylinder here, accounting for about a quarter of the PCB. This is an electrolytic capacitor. It ensures constant, stable output of energy. When you plug the adapter into the socket, it is powered by 220-volt AC, which is not a steady flow. We need an electrolytic capacitor to store the energy in advance, and then generate a steady flow to the battery. It works just like a reservoir, which stores water and controls how water flows through downstream waterways. Electrolytic capacitors have been put into use for nearly a century. The solution is quite mature, but the problem is the size gets bigger as the power increases, which leads to a bigger size of the charger. For example, a 125-watt charger will be larger than a 65-watt one. Now, to make the charger smaller, we must get rid of the electrolytic capacitor. Compared with traditional adapters, the PCB size of a 50-watt mini SuperVOOC charger is reduced by 52%. This is our breakthrough, non-electrolytic capacitor design. I'm 100% confident to see we are the first phone vendor to use such a design and make it available for mass production. To ensure the safety, the adapter is equipped with the expensive clamping diodes. This is a first in the consumer electronic industry, as clamping diodes are traditionally used in the aerospace industry. They can effectively absorb surges, and the adapter will handle all the voltage fluctuation from the power grid and deal with the surge so as to ensure the reliability. Fun fact, as it's an industry first to use clamping diodes, when we talked to a supplier, we nearly got rejected. Because in the beginning, they found it hard to believe why a phone vendor would purchase such expensive and high-standard components. They were worried about our BOM cost. The non-electrolytic capacitor design has a feature. The energy it generates for the battery is discontinuous. Will that work? Well, as early as MWC 2016, we unveiled the concept, low voltage pulse. As you will see from the flow here, compared with traditional adapters using electrolytic capacitor, pulse charging has a discontinuous 100 Hz flow. The flow on the oscilloscope looks like discontinuous, as it moves steadily over a cycle of 10 milliseconds, dropping from 5.5 M to 0, and then bouncing back to 5.5 M. Again, it's easier said than done. Our team has done a lot of work. The existing solution cannot support this mode. The stability of the circuit, the detection of the current and the voltage are all challenging tasks. Through a new design of the circuit and the customized chip, here is the trapezoidal wave. It ensures the energy efficiency of pulse charging. At higher power, its advantage will be more obvious. We've been working on pulse charging for 4 years. It's a well-verified, mature tech. And the prerequisite here is a direct charging architecture. I'm proud to say that the direct charging architecture that we have created is indeed pioneering, be it past or present. All the smartphones using OPPO flash charging have all been compatible with pulse charging. Compared with the traditional charging, pulse charging has gaps in the flow, and in these gaps, the polarization effect in battery will be eliminated, contributing to less wear and tear on the battery, and smaller changes of temperature, and paving the way for the next cycle of charging. In one word, we have developed a simple but efficient pulse charging, which is more battery friendly.
As I've mentioned, in this project, New Halley, we aim for small size, big energy. In the end, this 50-watt mini SuperVOOC charger has the size of a cracker and weighs like a raw egg. It shows how great things can come in small packages. To make it compact and capable, we have applied our proprietary cutting-edge technologies and made revolutionary breakthroughs, including the non-electrolytic capacitor design, pulse charging, and the high-frequency planar transformer. We have developed a brand new structure for the adapter. In product development, what is hard is not to add new things, but how you come up with something new by simplifying things. With the 50-watt mini SuperVOOC charger, we have finally achieved one of our long-term goals. Take pulse charging, which is actually the ultimate goal of battery manufacturers and device vendors. Now, that reminds me that 3 years ago, a battery supplier told us only VOOC has the potential to bring pulse charging into reality. One more thing. Now that we have a mini 50-watt charger, what about a higher power charger? Can it be smaller? Introducing 110-watt mini flash charger. Again, no burden at all. The power density is as high as 3.08 watt per cubic centimeter, which is 3 times that of other mini adapters in the market. The 110-watt mini flash charger also features a non-electrolytic capacitor design, pulse charging, and GaN high-frequency switch. Also, on this 110-watt high-power adapter, we have adopted a two-way architecture, DCX and DC to DC. One of them will convert the current, and the other will adjust the voltage. Each has its own duty, and that has increased the efficiency. Compatibility-wise, both the 50-watt mini SuperVOOC charger and the 110-watt mini flash charger aim to deliver flash charging to all devices. They support PPS, PD, and QC. In this case, it's not just about smartphones and tablets. They can take care of your laptops as well. So, that's all for today. 125-watt flash charge, 65-watt air VOOC, 50-watt mini SuperVOOC charger, and 110-watt mini flash charger. These 4 technologies well embody our theme today, flash forward. In flash charging, our pursuit goes beyond the speed. Be it wired charging or wireless charging, we have set the fastest record. But there is plenty more that we can do and should do. We should keep exploring more possibilities in charging and develop revolutionary technologies that lead the industry, just like pulse charging. We also dive into other topics like battery cycle life and safety. will continue to play an active role or even take the lead in standard formulation and increase the penetration of direct charging system. I've kept saying, make flash charging available to all devices. In the 5G era, we hope that there will not be such a thing as low battery anxiety, nor do we have to wait for a full charge. Now, fast charging is already available to smartphones, tablets, and laptops in the office and at home. In future, fast charging will apply to more devices like earbuds, smartwatches, cameras, or even any other electronics, and not just in the office and at home, but on buses, trains, airplanes, in cafes, anywhere. That's what we mean by making flash charging available to all devices. It's the direction that we're constantly working towards. And I know you all wonder when these techs will be available on the products. Well, the techs are in our arsenal, and the product teams will launch them when they see fit. That's all my sharing today. Thank you very much.